Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, on this part, what I'm going to be going through is the Wired Assurance Service Level Expectations, or SLEs, on Juniper Networks Mist solution. Now, if you don't know what Mist is, if you don't know where it is and what makes it up and all the advantages and benefits it brings to many different verticals and sectors for enterprise networking, then highly recommend you start here. Check out this link. It's a video that I made that describes all of that and a bit more. But as I said, this video, this part is about wired assurance, about those service level expectations. And in the Mist language, what is wired assurance? Wired being the key word. When we talk about wired, what we are actually referring to is the switching network itself. Whether it be access, distribution, or core, or campus fabric, it really doesn't matter. That's not the context here. The context and the meaning is all in those service level expectations, i.e. if you are that administrator, if you're that network operator or team that's responsible for that switching network and the architecture and the connectivity, you define what your expectations are for those clients that are connecting to that wired network. And those clients might be access points, and then you've got X amount of clients, ourselves with our iPads, laptops, handheld scanners, phones, etc., who are connecting to the access point over some kind of Wi-Fi technology. Or maybe it's a wired client, maybe it's a cache point, maybe it's a server that needs or has that RJ45 wired connection. So when you hear wired assurance, it's generally referring to the switching or wired network itself, but it's really those service level expectations that will give that network operations team, administrator who's responsible for that switching wired network, all the deep insights into what's happening on the switching network, what's impacting the end user's experience, where is it impacting in terms of VLAN, switching, ports, etc. And of course, using AI, what do you need to do to resolve those networking issues? And that's what we're going to be going through in this video. But first, let's start off with what are those service level expectations for wired assurance? Okay, so let's start off defining what are the service level expectations, or SLEs, as you're going to hear me abbreviating that to, for Juniper Networks Mist solution within the wired assurance. Now, to get to those SLEs, to start defining what they are, first I need to bring out my artistic skills, or lack thereof, and draw a network diagram. Now, don't take this network diagram too seriously. Obviously, this is just explaining the overall concept of those wired assurance SLE. So, don't take this too seriously in terms of my artistic skills and the network diagram. So first, let's actually draw a switch itself. So this could be a access layer switch, just for example, and I'm just going to call it a SW switch here for short. Now, are you only going to have one switch on your network? Maybe if it's an extremely small network, but the reality is that in most networks, there are more than one. So now I'm just going to draw another switch here. So this is another switch, and these could be our access layer switches. Now, the access layer switches, they're not going to connect to the internet directly. I doubt it very much anyway. So maybe there's a distribution layer switch as well. So here I'm just going to draw some more switches. I'm just going to put D here for distribution switches, and maybe those access layer switches have connectivity to both of these switches for redundancy and resiliency purposes. And maybe they're in a lag, or in the EVPN world, maybe they're utilizing ESI lag as well. Separate topic, but I quite like EVPN. And maybe these distribution switches are then connected to two core switches. And again, cross connection for redundancy and resiliency. So let me put in distribution here and core layer switches. And then right at the top, we're then going to have some kind of WAN connectivity, or SD-WAN connectivity, aren't we? So there's going to be a Juniper SRX or Session Smart Router for providing that WAN, IPsec, maybe secure vector routing with the Session Smart Routers WAN technology. Now for the WAN assurance, for the wired assurance, I was going off topic there. And as I've already said, what this is actually referring to are some key service level expectations, the insights into what is happening on the switching network itself. So whether it be access layer or distribution layer or core layer switches, it really doesn't matter in the context of wired assurance, because those service level expectations are looking at, well, what's happening on the switch? What traffic's been impacted by these switching networking events? Who's it impacting? How's it impacting their experience? And whether that be at the core, distribution or access layer, it really doesn't matter in that context. But as I've said before, on the access layer switches, there could be missed access points, just for example, and connecting over Wi-Fi to those access points are going to be ourselves. We're going to be there with a mobile phone, maybe with a tablet, or maybe it's some kind of handheld scanner. That's my picture for a scanner. I thought I was getting better with my drawing there until I've just done that. But you get the idea. It's these wireless clients who are connecting over Wi-Fi to that access point. And then the access point has connectivity into the switching network, typically over a trunked interface. Or maybe, as I said, you've got some kind of server on camp, some kind of server or another kind of wired client, like a till point. I do a lot of work in the retail sector, so I'm typically always going to be referring to retail devices like handheld scanners and cash till points, etc. But regardless, maybe these devices are connecting in over that wired connection, over that RJ45. But again, bring it back to the wired assurance. The wired assurance with those SOEs is only interested in that switching network itself. If you want to have the service level expectations into the Wi-Fi network, i.e. onto the access points, the missed access points themselves, that will be wireless assurance. And if you want the insights into the WAN-SD-WAN, that would be, guess what, WAN assurance. So as a general differentiator between what is wired assurance, WAN assurance, and wireless assurance, there you go. WAN assurance is looking at the SD-WAN-WAN. Wireless assurance is looking at the Wi-Fi, the access points and the devices connecting to that Wi-Fi, to that wireless LAN, to that access point. But for the context of this video, wired assurance is about the switching network itself. But where is Mist in terms of this grand picture? Well, if you've watched the first video, Mist is all the way over here where it's and this is my picture for a cloud. It is a cloud-based solution that is also utilizing artificial intelligence, or actually several different forms of artificial intelligence, and microservices as well. So in short, there's no on-premise controller with Mist. Everything's hosted in the cloud. And when you want to do configuration of your switching network, or of the WAN network, or of the Wi-Fi network, the access points, doesn't matter. The configuration is actually made as such. You define it on the Mist org in the cloud, and that is then pushed down into the network, and then they install the configuration. But obviously there's n times telemetry, or x amount of telemetry that's happening on the network. So every access point is sending up over 150 states of information of telemetry to the cloud solution, to Mist, and it's the same for the access, distribution and core layer switches, and even for the WAN. So all of that telemetry is then coming up to the Mist cloud. Now I just said key number, and that was really referring to the Wi-Fi network, to the access points. They are sending up every minute over 150 states of telemetry per client. And that's obviously a lot, and it's the same for those access, distribution and core layer switches. Every minute that telemetry is getting sent up to the Mist cloud. Now, as I said in my previous video, you do not want to be that person that's going through all of that information, all of that data, because that's going to be a never-ending job. It's not going to be pleasant. So what the Mist artificial intelligence does is it's going to classify all these states of telemetry into service level expectations. Now, for the wireless assurance, there's 7 different types of service level expectations, or SOEs. For wired assurance, there's actually 3 different types of service level expectations. But again, the key word is expectations. If you're that operator, if you're that administrator, if you're responsible for your switching network, you can define what is your expectation for clients that have connectivity over your switching estate. What's your expectation in terms of their experience? And then the artificial intelligence, using all of that data, it's baselining what's normal on your network and thus able to determine what's an anomaly, what's wrong, where's it deviated, and give the insights into, well, what's actually caused that in the first place. But what are these 3 different types of service level expectations? And I've just changed the color of my pen just to make things a bit different. But the first service level expectation I want to go through is throughput. Now, we all generally know what throughput is. Frames sent, frames received, the difference thus being the throughput, and of course frame loss, packet loss, etc. But throughput is just generally how fast can you send frames, can you send packets until there is loss, which could be caused by a number of different factors. So throughput itself is quite generic. Now, the AI on Mist is classifying the throughput that you get on the switching network and the amount of user minutes that have been impacted by different classifiers, i.e. the throughput as an SOE. It has a number of classifiers which is going to classify out, well, throughput is being impacted by this, throughput is being impacted by that, because throughput, if you think about it, is quite a generic term, isn't it? And as I just said, there are n types of factors that can impact throughput. So one of the first classifiers of throughput is congestion. So congestion here is actually looking at when all these frames of packets are coming into that switch, they're going to go into a queue, they're going to be shaped, they're going to be policed. And congestion is actually looking at, on the output interface, what is the number of frames - packets that are actually being dropped, and how is that impacting user experience. But there's also congestion on the uplink. So how is this different? Well, obviously we've got this keyword here, uplink. So that is referring to what's happening on the uplink. Congestion is referring to the output interface itself, but there's obviously going to be a device connected to that port over that fiber, over that cable. And that's what the congestion uplink is actually referring to, because if that's another switch, or if it's another router, or you're a switch and you're connecting to a router, that could impact in terms of congestion, where it's a routing device and it's got all these routing policy and policy statements, etc., etc. Or maybe you're going over an aggregated Ethernet interface, an AE bundle, or maybe you're going over an extension module. And all these little different pieces can add to specific congestion. Or maybe you're transmitting more than what that device can actually receive, as a good example. So congestion on the uplink. Another classifier for throughput is interface anomalies. And the key word here is interface. So what are the anomalies on the interface? Now, that doesn't mean dirt in the optical head on that fiber or anything like that. Not that kind of anomaly. What it's actually referring to is 3 different what's called subclassifiers. And you'll see all of this on the user interface. But maybe there's an anomaly in the maximum transmission unit that's defined on that switch port, maybe on all the ports on that switch. And if there's a mismatch on the MTU size, that is going to have an impact on user experience, because the MTU being different, maybe that's impacting OSPF and the routing instance isn't coming up, i.e. it's not getting fully established. Or maybe because of the MTU, packets are being dropped. But you've also got cable issues, and also negotiation, i.e. auto-negotiation failures as well. So all types of anomalies that can happen on the interface that would actually impact the end user experience. And then under throughput, there's also storm control. So when we talk about storm, we're referring to broadcast, unknown unicast, and multicast traffic, or BUM traffic. And the storm control, although it's not enabled by default, when it is enabled, it's set to 80% by default. So if there's any broadcast, unknown unicast, and multicast traffic that exceeds that threshold, i.e. 80%, it's going to be dropped, it's going to be discarded, that all those packets. But of course, that's then going to impact user experience, and having the insights into who's impacting and do you need to increase that threshold, obviously it's very valuable. And the final one for throughput is network. Now for the network, there are two sub-classifiers, which is your jitter and latency, i.e. all the service level expectations that can be impacted by networking events, which is inevitable, such as jitter and latency. So that is the throughput service level expectation. But as I said, throughput is quite generic, and that's why we've got these classifiers, which is classifying out all of that AI data, all of that telemetry, which has been sent from the network up to the Mist cloud, and it's classifying it out into congestion, or congestion on the uplink, or on the interface anomalies, or for storm control, or for the network. And for some of these, not all of them, but there are also sub-classifiers, which is classifying out even further all of that data into sub-classifiers, in this case MTU, cable issues, or auto-negotiation failures for the interface. But that is just one service level expectation. You also have, and I'm just going to write it here, successful connects. So for successful connects, and I'm not going to write out the sub-classifiers or classifiers for this because there's no more space on the page, but successful connects is as it sounds. It's, are the wired clients connecting successfully to that switch network? And if not, why not? Is it DHCP or is it authorization? Is it something like the radius server is not being reachable? Why is these clients not getting connectivity successfully to your wired network? And the other one, the last one just down here, because this is the third, we've got one already, we've got throughput, we've got successful connects, and the third one is switch health. And it is as it sounds. We're using AI data to understand what is the health of the switch. Is it running at high CPU? Is it running out of memory? Does it not have enough power? And as such, able to understand if the switch is of bad health, is this actually impacting, guess what, the end user's experience? So those are the three service level expectations, SLEs, for wired assurance up here. I always like to do this. It just puts everything into perspective before going on to the user interface. And that's what we're going to do now. We're going to go into the Mist user interface and see for ourselves what are those service level expectations. And so here we go. Here is the Juniper Networks Mist user interface, or GUI as it's commonly generically called. And right now we are looking at those service level expectations, or SLEs, for wired assurance. How do I know that? Well, it's just enabled in blue right up here, wired. That is the service level expectations for the switching network. If it was activated, because obviously it's a license, if it was activated for wireless assurance for the Wi-Fi network, you could also go into those service level expectations for the wireless network, the Wi-Fi network, and it's the same for the WAN, the SD-WAN, whether it be the session smart routers or the SRX devices, different technology really. We would get the insights, those service level expectation insights within that WAN tab as well. But really, to access the wired service level expectations, or whatever expectations, whether it be wireless, wired or WAN, first you need to go into the monitor tab here. And what you're seeing is, of course, all of that AI data that's been classified, categorized into those three service level expectations. Now under this tab here is where you can select a particular site. In this case, because this is just the live demo that's accessible around the world, if for Juniper people, this is the live demo. But this could be a particular switch as well. So if you've got one site, one switch, 10 switches or 100,000 switches, it doesn't matter. You can really filter down from a particular site to a particular switch as well. And not only that, and actually let me write that so we can actually access site, switch, and you can also view the clients in here as well. So if you knew or know of a particular client that is connected over wired connectivity to a particular switch, you know, its MAC address, etc., then you can go down to that level of insight as well. Or you can view all of that telemetry for the entire organization. So whether you want to have an org-wide view, a single pane of glass, and I'll show it in just a minute actually, or you want to see a particular site, or down to a particular switch, or even down to a particular client level, that's all done within this drop-down box here. And here is basically the duration of that data. So by default, the telemetry, the data is stored on the Mist cloud for up to 7 days. In analytics, there's a feature called premium analytics, which allows you to do a lot longer, up to 13 months of data retention. But really 7 days is enough, because these service level expectations, they're showing all the events, all the problems that really impact in the end user's experience. So if there was an event on the Wi-Fi or on the WAN or on the switching network, and that happened 90 days ago, 3 months ago, then really how valid is that? If there was a password authentication failure 3 months ago, do you really care about it? So 7 days is more than enough, because these are all events that you need to have the insights into and remediate as quickly as possible. But anyway, so we got the duration here, and of course you could do custom as well. So you could define your own custom range, a particular date, a particular time, duration, etc. So just as a generic overview of that user interface, this is what you're looking at. So we are looking at the service level expectations for the switching network, for the wired network, for a particular site, and for the last 7 days. And here are those service level expectations that I was just talking about on the previous part. So right here is throughput. Now, as I said, throughput is quite generic in terms of a definition, isn't it? Because there's a number of factors, as I said, that can and will impact throughput, whether it be on a wireless network, on a satellite network, or even in a switching network. Very generic term, throughput. Here is the second service level expectation. Successful connects. Are wired clients connecting to the network? Yes or no? And then we've got the switch health as well. So these are your service level expectations, all within that wired assurance, as I was explaining. But what you can also see just on the right hand side here, and I'm just going to draw a few boxes, all of these are what known as the classifiers. So the classifiers are classifying all that data. As I was saying, that huge amount of telemetry that's coming up from that switching network up to the Mist cloud, you don't want to go through all of that data, because there's a lot of data, and the AI is really simplifying all of that data into human readable and human actionable, human friendly really data into what's happening on the network, what's impacting those clients, and what do you actually need to do. So if we look at throughput here, these are all the service level expectations and the classifiers that are impacting those clients. And it's the same for successful connects and even switch health. So if we put this into perspective, when we look at successful connects, 54% of users, of clients that are connecting over some form of Ethernet cable to the network, they've only 54% of users for this particular site over the last 7 days actually connected successfully. And what you can see here is the classifiers are breaking out. Well, what's missing? Where's that missing 46% actually gone? And the classifiers are defining here that 100% of that missing 46% is due to authentication. Now that might be because the radius server is down. Maybe the radius server service is unreachable, or maybe the user's entering in the wrong password, or maybe the radius server hasn't been configured for that password, etc., etc. There's quite a few variations, but absolutely 100% of this missing 46% is due to authorization. There is 0% due to DHCP. So that's what the classifiers are doing, and it's able to do so at a very granular level. So if we look at the throughput, you can see here it's very, very good. It's at 98%, but that obviously stands to reason that there is 2% actually missing. And so the classifiers are then finding out what's happened to this missing 2%. Where has that gone? And that's what the classifiers are doing, is it's giving the actionable insights to that network operations team for that switching network as to what's going on with the network, what's going wrong, who's impacting, how is it being impacted? Is it DHCP? Is it authorization? Is it radius? Is it congestion on the ports themselves? Is it congestion on the uplink? Is it interface anomalies, etc., etc.? So that, just from a high level, is the user interface and what you're actually looking at here. And what is really, really good on Mist is that the documentation is publicly available. So underneath the question mark, just here, you can look at API documentation, courses, firmware updates, feature updates. So if I click on here, due to the microservices, the last update in terms of features was on the March the 29th, which is about just over a week ago at the time of me doing this video. But look at the period of these feature updates, and that's all due to the microservices architecture. But under here, you've also got the Mist documentation. And in the Mist documentation, you can look and just search for anything. So here I've actually been reading up on those service level expectations for the wired assurance, and it's all defined in here. This is great information to actually have. So kudos, well done Juniper Networks Mist for actually doing that. But let's bring it back. Let's bring it back a step. We're not here to talk about documentation. We're here to talk about the user interface. So what I'm going to do is I'm actually just going to initially focus on the successful connects, because this is okay, but it's not the best. It's at 54%. But if I click on successful connects, you can now see we've gone into more information into these classifiers. So we can now see more from a high level, as I was saying, that 100% was due to authorization failures, authentication failures. So if I click authentication, what you can see is that the authentication contributed to the failure of that SLE 100% of the time. But now we've got these sub-classifiers. You're not going to have a sub-classifier for every classifier. It really does depend. But what we can see in this sub-classifier is that 0% was due to the wrong credential. So there wasn't any wired client that was entering in the wrong credentials, the wrong password. But 100% of this missing 100% of that missing 46% was actually due to the radius server was just unreachable. So that might be a problem on the network itself. But if you just think about that, how quickly has the AI just immediately told you what the problem is on the network and gave that network operations team, that operator, the ability to know where to investigate, where to troubleshoot, what to actually look at to get that best mean time to innocence, as it's called in the Mist world. So that is why the successful connects is only at 54%, because that radius server is unreachable. So right there and there, I know if I was that operator what I need to look into. Now the other, I wouldn't say it's a major cause for concern, but the throughput is at 98%. Now again, throughput 98% is very, very good. I'm sure no one's really going to complain about that. But because of all that state of telemetry that's on the Mist cloud, what Mist is now able to do is able to break out that missing 2%. And again, let me write that again because my pen was automatically erasing my 2% marker. But the classifiers are again classifying out what's happened to this missing 2%. Was it due to congestion on that egress, on that output interface? Was it due to storm control, increase of broadcast, unknown unicast and multicast traffic? Was there congestion on the uplink? Was there network issues in terms of jitter and latency? Or were there interface anomalies, MTU, cable issues, that's not even a word, cable issues, or even auto-negotiation failures? But what we can see is less than 1% of that missing 2% was due to congestion on the egress port. So not very big. 0% was due to bump traffic. 0% as well was due to congestion on the uplink. But right here, just greater than 99% was due to this classifier here, network. We'll go into that in just a second, and less than 1% was due to interface anomalies. So just like we did with successful connects, if I now select network, we now have these sub-classifiers. And the sub-classifier is telling us for this missing 2% again, most of that was for network, and most of that was due to latency on the network itself. And now if I select latency, we can actually view the user minutes that has been impacted by this. So everything is, not everything, but most of the concepts with SLEs is due to user minutes. So let me put that into example. So let's say, for example, you have 10 users, just for example, and they're all utilizing the network resources for 1 minute each. So obviously 10 times 1, 10 users with 1 minute each, you've then got 10 user minutes, because those are minutes that they want to access the network or go through the network, go over the network to have really some kind of experience, ideally the best experience actually possible. Now, what is being defined here under user minutes is if there is 4 user minutes that is impacting or that have been impacted because of latency here, then that means that you're only getting 6 out of 10 possible user minutes on the network, so nearly fit or just over 50%. That's the whole concept of user minutes. It's how many user minutes are you getting over the network and how many user minutes have been impacted by those network events, those network failures, in this case latency. So what is being shown here is, yes, the latency contributed to more than or greater than 99% of that overall failure, that 2%, but this impacted 87.3 user minutes. Now you can put this into a number itself, so you can actually see there the amount of user minutes that were impacted for this particular site over the last 7 days. But I like to work off the percentages itself, but we can actually track the user minutes over those 7 days and were there any system changes on the switch itself. Now under distribution is where, under the distribution, we really look at the network itself, so the network being the switches. When we talk about switches, there are a number of different factors, of course, and different elements, but the Mist can define the VLANs, so we can see how that latency is spread across those different VLANs, whether you've got one VLAN, native default VLAN of 1, or 100 VLANs, or whatever, it doesn't matter. The AI is able to understand and show a user, an operations team, where that latency is distributed across those VLANs. We can also see what clients, and that's what we're seeing here, all the clients that have had their experience impacted by that latency and what interfaces this is actually on, and of course the switches themselves. So what we're actually seeing here is that this user here, and this is just a MAC address, connected to these 2 switches with these MAC addresses on these interfaces here, that client is not having a good time because that anomaly is 4.38 times greater than normal, than the baseline, more than what AI has learned is just the normal operations for this network. And it's contributing to 6% of that overall failure to meet that SLE. Really the big thing that you need to look at here is the anomaly. If it's anything like this number here, 4.38, that means that the anomaly is getting bigger. It's really impacted the user's experience a lot more over that time. But right at the top here, note here, View Insights. So if I click on View Insights, then we can now go into the switch itself. Now, of course, I can go into the client here and you can see all the general statistics and summary, and it failed to meet that service level goal 4.38 times because that is the anomaly. But we can also see what interfaces saw and experienced this latency over. What are those VLANs, as I was explaining, and the switches as well. What you can also do, of course, we can actually go into the switch. So this switch here has contributed the most to not meeting that SLE at 53%. And we can actually go into the switch, into View Insights, and actually see how is this switch actually performing, because you can see here immediately there's been a port going up, a port going down, maybe a few misconfigurations, or just a new switch being disconnected. So maybe there was a configuration error that increased that latency. And of course, what is the CPU utilization, and a lot more. But let me just bring this all back. How could you speed this up? And I've done this on my last video. I'm going to do it again here. Marvis VNA, this little box right at the bottom here. And as I always say, a chat box isn't unique. You get that on any website these days from all the different verticals, all the different industries. But Marvis VNA is absolutely unique, and this is so powerful. I promise you, you will not find anything else like this. And I'm willing to put my own money down on that, because this is it's a conversational assistant, but it's taking user input, putting it through an LLM or local language module, I think it stands for. And this has been reinforced by machine learning and reinforcement learning. And it's able to understand their user's question and come back with meaningful, actionable results. So right now, I could just ask, how is my switch, just for example. Note I didn't say a switch name, and I didn't even define a time period, so I could have been a bit more specific. But here's just come back saying, here's some issues for these switches, which I found today, May the 7th, 2024, between this particular time range. So here are the switch names. I didn't even have to tell a particular switch name. And I'm just going to go with it. I'm just going to see where this actually leads. So let's look at this switch here, and immediately for today, between this time range, there has been authentication failures and even latency. Let's look at the latency. This switch experienced latency on these ports. The latest consecutive latency was experienced for more than 1 hour. The most severe port flapping was on the Gigi 008 port, so that's when a port's going up and down and up and down. And just right here, you can go into the failure timeline, view what was this failure timeline, of course, and go into the switch inside itself. I don't want to show any more than that because Marvis Actions, Marvis Minis, Marvis Queries, Marvis VNA is something I want to show at a later video. But as you can see, that is extremely powerful. Just that AI data, it's just a wow factor. But let's just bring it back just quickly to show you how easy it is. So, I did want to show this. So under this drop down box here, you can go into the entire organization for Wired. So you can see the overall service for all the worst performing 100 sites by switch health or successful connects. So you can see a live demo here. Yeah, we know this at 55%, or successful connects or throughput for all the sites. But let's actually go back to a particular site, to site live demo. Let's do the last 7 days. Let's just reset it. And let's now show you some of the other sub classifiers. So I know, for example, storm control. I know, for example, for the interface anomalies, here are those cable issues. So even though throughput was at 98%, less than 1% of that missing 2% was due to interface anomalies. That's either cable issues, MTU, or negotiation failures, auto negotiation. But these sub-classifiers are further defining that 89% of that less than 1% of that missing 2% was due to cable issues. And again, just select here under distribution, and we will now be able to see what switches, what VLANs, interfaces, and ports that those cable issues, those layer 1 physical issues are actually on. That is the Mist AI service level expectations for wired assurance. And so there we go, everybody. That is the end of this part. That is the end of this series in the Juniper Networks Mist solution. And we've gone through a bit of detail in terms of what is wired assurance, but more so, what are those service level expectations? What do they actually mean? So the throughput, the successful connects, tongue twister, successful connects, and switch health. And what are the use of those classifiers, and in some cases the sub-classifiers, and general information around obviously how to investigate what does all that AI data actually mean and get to that root cause as quickly as possible, or even more quickly actually use Marvis VNA. I always bang on about it because it is such a unique, powerful feature at the end of the day. I'm not just saying that because full disclosure, I work at Juniper Networks, but I'm sure you can appreciate that that is really, really powerful. So if you like this content, if you like my video, please give me a like. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. Other than that, thanks for watching and goodbye.